Today we're going to write a program that we can convert any real number to any base, and we're going to extend it to every base. To cover all possible bases, we will need to extend it into base 36. For now, let's look at what certain numbers are in base 2, which is just binary. Example: 50 is 110010, and so forth. But fraction parts, what do we do for that? Most computers on the calculator can only convert the int part, and also to only binary. $50.2 is 110010 period 0011001100, and so forth. For the integer part, you always look to the digit to the left on just the int, and on the fraction part you pay close attention to the decimal, to the digit to the right of the decimal. So example: 50.375 in binary is 110010 period 011, and our current base for that is in base 10, which is what we usually use, and our target base for this is in binary. First, we're going to divide by the target base, which is 2, and we're going to mark all of our numbers in a vertical column starting at the top. If it yields a remainder with 1, we're going to, well, if it yields a remainder, we're going to mark a 1 and note that. If no remainder, we're going to mark it with 0. And for this, we're only using the integer part. We're not using the fraction part just yet. We're going to continue working through it until our integer is equal to 0. Then when we're done, we're going to inverse the column, reading it from bottom to top. For example, 50 divided by 2 is 25, with no fraction. 25 divided by 2 is 12.5, which has a fraction of 0.5, so we put a 1. And now we're only going to use the int part, not the 0.5. We're going to use just the 12 divided by 2 equal to 6. No left over, so it makes a 0. 6 divided by 2 is 3, no left over. 3 divided by 2 was 1.5, with a remainder. We put down 1. And the 1 only divided by 2 has a remainder. And now, since our integer is a 0, we stop. And reading it from bottom to top, we have 110010. Now for the fraction part, it's backwards. Instead of dividing, we're going to multiply the remainder, and only the remainder, by the target base of 2. We're going to look at the integer part as well. If the product is equal to 0, then we're going to note a 0. And if the product is equal to 1, we're going to mark a 1. And we're going to keep doing this until the fraction part is a 0, so we have like a whole number. And this one, we're not going to inverse the order. We're only going to read it from top to bottom. So the 0.375 part is all we're doing here. Multiply it by the target base of 2, you get 0.750. No integer, so mark a 0. And when you multiply that and just the 0.75 by 2, you get 1.5. and we're going to use this. Then we're going to multiply just the 0.5 by 2, and then we're going to get a 1. That's what I'm noting, that we're only multiplying by the fractional part only. And with this, we're going to go from top to bottom, and we get that. So the integer, we go from bottom to top. Fraction part, we go top to bottom. Let's head on over to our Python shell and make a new file in our IDE, which is our Integrated Development Environment. Let's start writing our scripts for this. First thing I want to do is do some initialization. We're going to have some letters, because for each digit we're going to have the values 0 through Z. So we have to have a way of converting those two. I'm going to use dictionaries for this. Now let's go ahead and type some of our numbers. So in case we're going from a smaller base to a larger base, we can convert from the number to the letter as well. Alright, now let's write some of our functions. Okay, what this is going to do, first we're going to pass it the value of the int, of whatever integer we're going to have. Then we're going to pass it the value of the current base. This will be the first thing we enter. And then it's going to set the count to 0 for every time it runs. It's going to check the length of the integer. And while the count is less than the length, it's going to see, is it an alpha? Is it a character? And if it is, it's going to pull that value from the top. And then it's going to always capitalize it as well. Or, if it is not, it's just simply going to make the integer version of the string that we enter. And then we're going to see if the length is less than, if my count is less than my length minus 1, the decimal will equal the decimal plus my dig, which is the int here. Or if it's not, this is your catch-all. It's just, and afterwards it's going to put my count up to 1 every time to make it up to the length. So for each character in the integer we enter, and once it'll put them all together and return this as output. Next, we're going to need one to deal with just the fractions. So far, all we have is for any to des int. Okay, so this one is just going to be the inverse of this one. Instead of taking the integer to the decimal, we're going to do the decimal to the integer. So that's all this does. Instead of multiplying it, we're going to just be dividing it and dividing it modulously by the base to get our result. And then we're going to return it as well. So whatever argument we pass it, we can return it and set it equal to our value. Okay, now we're going to do one for the decimal to a fraction. That would have been interesting. Okay, what this is going to do is we're going to pass it the decimal part and the base of our starting number. And what this is going to do is check to see if the product is equal to, or not equal to 0, rather, and if the place is less than or equal to 10. Because we don't want digits that are extremely long. We're just putting it down to 10, so then the computer doesn't take forever to compile this. It'll give us a good rounding factor. So what this is going to do is take the results and multiply it by the product, and which is just what we just put here, times the base. The product times the base is the result. And the digits to the left, digits to the right, is what we're going to split from my result. So we're going to multiply them together, split the result, and we're going to keep checking our digits until our product is equal to 0. And then when it is, when our place is equal to, or if our place is higher than 10 or that, it'll return the new fraction part. Okay, now we're going to make it run. This is where we're going to collect some of the data as well. So I'm going to put here, collect data, and we're going to get all this from the user. And the reason I'm putting a real number instead of just number, I'm trying to specify very specifically that it has to be a real number, not just an integer. That way, instead of putting 10 or 28, it'll be 10.0 or 28.0. And what this is going to do, it's going to split it wherever we put our period. So it'll automatically assign my int to the integer, and the fractional part will be on the other side of the decimal. Very simple. This can be the base for the starter number. Forgot my other dancing partner. Okay, now we're going to do the new base. I'm also casting these as an int just to go ahead and have them for an int instead of a string, because raw input always returns a string. A little too fast. Alright, that's nice. So we're going to collect 4 variables from them. We're going to ask them what number they want, and it's going to collect the integer and the fraction, the current base, and the target base. That's what we're going to get from them. Go ahead and save that. Now we're going to do some work. Okay, so this is just going to stitch them all together. And we're also... Yeah, okay, these are already strings. Right here. So, I'm going to have to cast as int later on. But currently, these two are fine. And we're going to put a decimal between those. And a comma between that. Yeah, because... did not mean to call it that. My line. Okay. And we're going to string those two, because you can't really combine ints with strings unless you cast them. So that'll take care of that. Okay, this is just going to split this. That's all it's going to do. It just makes it a little bit easier for us to convert it later. And we better go ahead and cast this as well. Okay, so here's where we're going to start compiling some of this into our functions. We're going to capture that, and we're going to go ahead and pass it our integer and our base to do my end result. And then we're going to do the same thing with the fraction, if we spell it right. Okay, and then we're going to change them around. Alright, that's going to be all our results for now. Now, let's go ahead and print some of this stuff out. And then we're going to move on to some of the trials. Alright, that should be okay for us. Alright, let's try some of this stuff out. Save it. Please enter a real number. From our earlier, let's try just 50.0. Or we can try 50.375 because we know that does convert pretty easily. And its base, source base is number 10. Target base is 2 for binary. And right there, 50.375 in base 10 is 110010 period 011 in base 2, which is correct. So let's try something else. Let's try maybe A5 point C3. Well, maybe not 3. I think C4 would work better. And we'll put that at base. It has to be higher than 10. We'll just try base 36. And we're going to convert that down to 10. Yeah, that's right. That'll work. Alright, thank you. Yeah, let's try a few more. A lot of programming like to use hexadecimal. Like in the original Legend of Zelda, you can only have a maximum of 255 rupees. Why is that? Because that is what fit in really well. So that would be FF, 0.0, And that is base 16 because it's hexadecimal. And convert it down. 255. Other games like to use 999, which is what, 3, isn't it 3E7? I think so. 3E7, 0, 16, 10, 99. Or if they want a bigger number, sometimes they just use like 99 to get. Whoop, I didn't put a 0. That's my problem. Nope. 0.0, base 10, in 16, should be 270f.0. Well, it's not going to put a 0, but 270f, right there.